Have you ever pondered the importance of gravimetric analysis in the grand scheme of chemistry? It's a cornerstone of the discipline, allowing scientists to quantify the amount of a specific element in a substance. Today, we're diving into a fascinating experiment, the gravimetric analysis of nickel as dimethyl glyoxime. We begin with a clean 400 milliliter beaker and carefully measure 20 milliliters of a given nickel salt solution into the beaker. Precision is key here, as it sets the stage for the rest of the experiment. Next, we add 5 milliliters of a 1:1 hydrochloric acid solution, diluting the mixture with approximately 150 milliliters of distilled water. This process prepares our solution for the reactions to come. Now, we gently heat the solution to around 70 to 80 degrees Celsius. When the temperature is just right, we introduce 25 milliliters of an alcoholic dimethyl glyoxime solution, stirring constantly. This is where the magic happens. The dimethyl glyoxime reacts with the nickel, starting the precipitation process. Without missing a beat, we add ammonia, stirring continuously until we detect the characteristic smell of ammonia. This step ensures the complete precipitation of nickel as dimethyl glyoxime. We then let the beaker sit undisturbed for a while, allowing the precipitate to settle. Once the solution has cooled, we check for complete precipitation by adding a few drops of dimethyl glyoxime in a clear section. The next step requires a deft hand, filtering the precipitate using hot water and Wattmann filter paper. We wash the precipitate with hot water several times to remove any impurities. Finally, we dry the precipitate and weigh it. This weight gives us the amount of nickel present in our initial solution. In this case, the percentage of purity of nickel in our sample was found to be 85.1%. To recap, this experiment involved a measured approach to gravimetric analysis, where we prepared a solution, initiated a chemical reaction, precipitated and filtered nickel as dimethyl glyoxime, and finally weighed the resultant product. The result? A clear and quantifiable measure of nickel content in our solution. Gravimetric analysis, as demonstrated, is not just a vital tool in the chemist's arsenal, but also a fascinating process to observe. It's a journey that begins with a simple solution and ends with the precise determination of an element's presence. So the next time you encounter a seemingly complex chemical experiment, remember, every step, every reaction, and every calculation has its purpose. And that purpose is to unravel the mysteries of the universe, one element at a time.